Okay, let's get started. I've had to start a second notebook here. I'm taking the notes 4 times each section, so I ran out of paper. So this is going to be section 3.4, Angles with Circles. So section 3.4, Angles with Circles. Let's go ahead and get started. So we'll say 3.4, Angles with Circles. We need some vocabulary from section 1.5 first. So I'll say vocab from section 1.5. And what we need to do is include 5 pictures of circles here that we're going to label. So 1, 2, 3, 4, 5 pictures of circles. So for our first diagram, we're just going to label that circle, and then maybe get a draw the center of that circle and write the word center. For our second diagram, we'll have the center marked, but then you need to draw in what would be a radius of a circle and then label that circle radius. So radius is the segment from the center of the circle to the edge of the circle. Our next circle will also label the center, or mark the center, and then I think we should get a figure going through there, a segment going through the center that's a diameter. So a diameter goes from one side of the circle to the other side of the circle through the center. In our fourth diagram, we'll have a center marked, and then this is going to be a chord on a circle, and a chord is just any segment that does not go through the center. So it touches both sides of the circle, but it doesn't go through the center. And then our last figure, we need to mark the center of the circle, and then we're going to draw in a line that just brushes up against the edge, and that is called a tangent, or a tangent line. Now we have some important ideas here with angles and circles. So one of the important angles is called a central angle. And in order to do this, let's draw a picture. And we will mark where the center is, and then I'm just going to put in 2 radii, 2 radiuses. See, central angle is an angle with a vertex at the center. And I suppose we should be specific. Center of the circle. And then the endpoints, so I'll say and endpoints on the circle. Now, these angles have measures. So there's an angle measure here that we can calculate or measure, and then that is identical to this arc measure on the outside. So it's important to note that the measure of the central angle is the same as the measure of the intercepted arc. Now if we were going to give a little bit of an example here, or maybe some notation, let's just add some notation. So let's call this point A right in the middle of the circle, and then we'll put a D here, and we'll put a B down here. So we could say then effectively that the measure of angle DAB is equal to the measure of arc DB. And I want to remind you that arcs, we put 2 letters, and then you draw a kind of a rainbow over the top of that. Another type of angle that we have is called an inscribed angle. So let's get a picture again. Get yourself a nice circle. And then an inscribed angle looks like you've got one vertex on the circle, and then you just draw 2 chords. So this is a angle with a vertex on the circle. And then we should probably also say, and it has endpoints also on the circle. Now if we were going to do some of the same notation as we did before, we have a measure here, and that particular measure is related to this arc measure outside. We call that an intercepted arc. So the relationship there is one is twice as big as the other, where we would say the measure of the inscribed angle is half as big as the measure of the intercepted arc. So if we're going to label this a little bit, I'll put a U up here, and then a P, and then a C. So we would say in this case, the measure of angle UPC is equal to 1/2 multiplied by the measure of arc UC. Now we got a big OR here. Maybe I can put a box around that. You could also say 2 times the measure of angle UPC is equal to the measure of arc UC. So those 2 ideas are important. Now, lastly here, we're going to put in 3 important relationships here. Okay, so I'm going to try and divide this space into kind of 3 same-size pieces. So in our first important relationship is between a tangent line and a radius. So I'll draw my best circle. And then let's put in a radius. So a radius goes from the center of the circle to the outside edge of the circle. And then a tangent line goes, brushes up against the circle. And what I want to do is look at the relationship between the tangent line and the radius at the same point. See, there's a really important relationship there. And that important relationship is that those form a right angle. So I would say then a radius and a tangent line meet at a right angle. That could also be a tangent segment, but they meet at a right angle. Our second important relationship is between a radius and a chord. So I'll draw another picture to illustrate this. We've got a circle. I'm going to draw in a radius. Let's make our radius go this way this time. So that's a radius. And then I'm going to draw in a chord. Now I'm going to try and draw this in a very specific way. I'm going to draw the chord from this point down through the radius and then to the other side of the circle. So notice that it doesn't go through the center, but what I want to do is make sure that this chord and this radius are at a right angle, because that's the important relationship. You see, if, and this is if the chord and the radius intersect at a right angle, then you can say that the chord gets cut in half. That's the important relationship. So if a chord and a radius and a chord meet at a right angle, let's write that. If a radius and a chord meet at a right angle, then the radius bisects the chord. And then just remember, bisects means cuts in half. Our last important relationship is about inscribed quadrilaterals. So we're going to demonstrate this just by sort of building this diagram. The first thing I'm going to do in this diagram is draw in an inscribed angle. So I've got this inscribed angle, and I'm just going to eyeball this a little bit. I'm going to say the measure of that inscribed angle is A. Now, one thing that I know for sure is that on the outside edge of this circle, and I'm using like these dotted marks here to mark off this is the outside edge, that measure of that arc is going to be 2A, twice as big. Well, if you choose a point anywhere on that arc, I pick this one. And then connect the other edges, you're going to make another inscribed angle. Let's call the measure of that inscribed angle B. Now, if you draw a orange arc going all the way around the outside here, that's going to be a major arc now, because that's more than halfway around the circle. But that orange arc would have a measure of 2B. So that must mean that if I add together 2A and 2B, that goes all the way around the circle, so it must be a 360-degree sum. Now I notice that all of these terms are even, so I can cut them all in half. I could write down an equation that said A plus B is equal to 180. And that is the important relationship. You see these angles that are opposite in, this is called an inscribed quadrilateral. Those opposite angles are supplementary. So we'll say for an inscribed quadrilateral, opposite angles are supplementary. you've got some important notes there. We're going to look at some 4 different examples now.